1994 on velocity time graph as our example. So the question says, the diagram above represents the velocity time graph of a body in motion. The total distance covered by the body is 195 meters. Calculate the acceleration of the body in section OP of the graph. In section OP of the graph. So section OP, this is OP. So they say we should calculate the acceleration at this section. And of course, we know that this section of the graph, OP represents acceleration. Then PQ represents zero acceleration or constant velocity. Then Q to the end represents deceleration, that's negative acceleration. So we have to find the acceleration OP. And we know that the slope of this OP, the slope of this inclined side of the graph usually represents what? Acceleration. And you know that acceleration A is what? Change in velocity over change in time. And our vertical axis represents velocity, horizontal axis represents what? Time. So the acceleration of OP will be what? A will be equals to B2 minus B1 over T2 minus T1. However, we have a challenge here. The challenge here is that we don't know our V2. Our V1 is 0. Our V2, or we call it V here, we don't know what our V here. And if we don't know what V is here, we cannot calculate that acceleration. So the first thing we have to do is to find this V. And then they've given us the parameter that the total distance covered by the body equals to what? 195 meters. So from this data here, we're going to use it to find our velocity first, our maximum velocity. Then with the velocity, we can now use it to find what? Acceleration. So let's proceed. Now, you recall that total distance D equals to what? Area of the graph, area of the shape formed by the graph. And what kind of shape is this? A trapezium, which equals to area of a trapezium is a half of the parallels of the sum of the parallel side, half of PQ plus what? I don't know, whatever we call it. If you call this one OR, or you call this place R, thing like that, OR. Then times the height. Area of the trapezium is what? A half of the sum of parallel sides plus, times the height. But the height in this case is represented by V, velocity, times V. So if we substitute, our D, which is the total distance, is 195 equals to a half. Our PQ, that's PQ, the distance, the length of PQ will be what? 11 minus 6. And 11 minus 6 is what? 5 plus. And then OR, which is from 0 to this place, is 21. Okay. So we proceed. So our D, okay, our 195 will now be equals to 1 over 2. Sorry, we forgot to write our V times the height, which is V here. 5 plus 21 is 26. That will be times 26 times. So 2 will cancel itself 1. Cancel 26 how many times? 1 and 3, 13 times. So we have 195 equals to 13 V. So to make V the subject of the formula. So to make V the subject of formula, we divide both sides by 13. We divide both sides by 13. Thirteen will cancel 13. This will cancel this 15 times. So therefore, our velocity, our maximum velocity equals to 15 meter per second. However, we were not asked to find the velocity. We were asked to find acceleration. To find acceleration of the point OP. So our acceleration now will be acceleration A, which is change in V over change in T. Our change in V is 15. Our maximum V is 15 minus 0, while that of our T is let's look at it again. Our T is 6 minus 0. 6 minus 0, while our V is what? 15 here, which is 15 now minus 0. It will be 6 minus 0, which equals to 15 over 6. So if you do that math there, this will be 2.5 meter per second square. The unit of acceleration is meter per second square. So the acceleration between point OP equals to what? 2.5 meter per second square. Thank you.